So the burning question is, does the way I edit photos on Instagram affect my level of engagement? So I'm Emily here with Professor Williams of BYUI, an expert in research and analytics to answer this. So let's just start an open discussion.
Well, that's kind of you to say I'm an expert, but let's do our best. Let's do our best. Let's start with what you did. So the first thing that you did is you used a piece of software. Describe the piece of software that you put 400 pictures into.
Yes, so we took 400 professional photography photos on Instagram and put them all through Adobe Capture, which is an app that any of you guys can get on your phones, Androids, all of the good stuff. And we took out the HSB values of all of these 400 photos, which includes hue, saturation, and brightness, and took all the values out and punched them into
Tell
Excel.
me a little bit about the group, how you pick your Instagram photos.
So we actually did 3 different groups of action sports photography, landscape photography, and wedding photography.
And you just use those hashtags.
Yeah, so we looked for good, I would say quote unquote good performing photos with a lot of likes and comments, photos with not so much, just so we could really see what's driving people to like the photos. If there's any correlation.
If there's any correlation. So again, how did you pick the photos? I'm sorry that I'm pushing a little bit on that.
No, you're good.
How did you pick them?
So
you went into Instagram, and what did you type in?
We typed in either hashtag landscape photography, because that's a really popular landscape photo hashtag. We typed in hashtag wedding photography, hashtag action sports.
Okay, so
yeah.
you have those. And how did you pick? Was it just the first?
Random, yeah.
So you just picked up the first chunk that came up?
We picked up the first chunk that performed well, and then we kept scrolling to find ones that didn't perform well, because hashtags is the best way to do that, because that's how smaller creators try and get engagement, is through hashtags. So
that didn't perform well. So you just literally you kind of then did a sort by highest to lowest, and you kind of pick the extremes a little bit?
A little bit, yeah. It's hard to find photos that perform in the middle, just because newer creators obviously don't have as much followers, or creators that don't do as well because their content have little to no followers as well.
Sure. One of the things that as we're going to get to your findings later on, and they are interesting, as we were talking about it. So if I were to advise you going forward, I love the science project, but if we were to do this another time, I would have invited you to be more consistent on how you picked them, so that all of your people were the same type of people. That way you're doing what's called controlling for the input. So you specifically controlled low and high performers.
Why don't you explain what controlling is?
So what I mean by controlling is when you're doing an experiment and measurement, you want the categories that you have to be the only categories that you're measuring as much as possible. But what happens in stuff like this, you deliberately picked high performers and low performers. Well, what causes people to be high performing and low performing is they're new to Instagram, and they've been in Instagram a long time, or they've been paying, to do some stuff, right? So you whatever the reasons are that people become high performers is now shaping the likes, which is our ultimate measure.
So you're saying there's outside influence
on what your ultimate outcome, what your measurement's going to be, and that's going to skew. And the word in science is it's going to bias our results.
So in future analytics,
if you were to do this again, you'd want to have, maybe
really funnel down.
Maybe even just like 5 people who do landscape photography that have basically the same average number of followers. And the same, and then you pick. So we would call this more random in your approach. And so that you're trying to make it so that which one performs well. So you literally pick people who performed well for a lot of reasons, and then we already know they performed well, and so we're over emphasizing things that don't have anything to do with hue, saturation, brightness, as we talk about. It's not a big deal. Your findings are still interesting, but next time we do this, that would be a step that we want to take. Does that
Okay.
make sense?
Yeah, no, that totally makes sense. And
Yeah.
that's actually a great resource because
Yeah.
we are giving our listeners a
What to do
interactive
next.
Excel sheet that they can do this on their own. So that's a great tip
Yeah.
to...
Yeah, so that really is, and then I think that actually explains why what we're going to get to, I think that explains why we don't have strong results. The fact that we don't have strong results is not necessarily bad science, right? It's not necessarily bad analytics.
It just means that there's other factors at play,
the other
which are
factors at
very
play
important.
that we actually really, that we're actually probably seeing, and we may or may not be able to measure very strongly what we're looking at.
Mm-hmm.
Though we don't know that for sure, because as we talk about, we eliminated some of the outliers as we looked at it. So the second thing, the question is, describe for me hue. What is hue?
So when we put the photos through Adobe Capture, it popped out 5 values. It popped out 5 colors that we selected as a palette, and it popped out H, S, and B, which hue is, as we're talking about,
So
is
it
the
picks up
color
5 colors,
value.
and those it looks around the image and it picks the 5 most prominent colors.
Yes, the most
So
representative
if I were-
colors.
So something like if I had a fall shot, it's
The
going to
reds,
be picking
oranges,
the reds, the oranges,
yellows.
maybe a little bit of the brown,
Yep.
and maybe right,
Absolutely.
maybe the blue sky, and it's going to pull that up and say, okay, these are the 5 colors. And so then, what is hue? Hue is a measurement of those 5 colors. Where
on
they,
the rainbow wheel.
On the rainbow
so
wheel.
on the left, so if you get a lower hue value, so like 5s, 10s, 20s, 30s, it would be reds, oranges, yellows, maybe a tiny bit of greens. If you get more in the 300s range, then it would be like purples, blues, violets.
Right. Just like you can think of a rainbow.
Yes.
And so what you're doing by measuring these 5 values, so if I understand correctly, what you did is you took those 5 values and you had numbers, and we basically summed them.
Yes.
So so we were talking about whether we sum or average those 5 hues, and the advantage is to average them because as you average them, that shows the typical hue. Is the most, basically you're saying is this image on average, is it kind of more red or more indigo or whatever it is?
Yes.
And
The most prominent
and so
color.
what is the most prominent color is the way to say it. And so we're going to average those 5, and you're averaging it. And the second thing that we looked at is saturation. And my understanding of saturation is that it's how gray it is, and the less the less gray it has, the more saturated it is.
Yes. So on the speaking numbers, the lower the number is, the more gray it is, and then the higher the number is, the more colorful it is.
So what you're trying to do is you're trying to get the range between those two. So you're looking at, of those 5 colors, the one that has the most gray, and the one that and then the one that has the least gray, and you're seeing the difference from it. And so that shows you a kind of a variegation, right? A
Yes.
variety of those two.
Yes.
And so you're asking if it has more variety, is it therefore, is that going to cap people's attention? And so you looked at the minimum of those 5 numbers and the maximum of those 5 numbers. On
And then we
saturation.
input to see the
Right.
range
And then
of
you got a
saturation.
range. Yeah.
Yes.
Okay, and you did the same thing with brightness, and brightness is from white to black.
Yes, so the exact same principle. The lower the number, the more black it is. The higher the number, the more white.
And so what you did then is you were looking at Facebook engagement or Instagram engagement, and there are the 2 metrics. There are the likes and the comments.
Yes.
And we felt like that a person who comments, you felt like a person who comments, that shows
It's
a
more
higher level of
valuable,
engagement.
yes.
And so we times that by 3.
Yes.
And so you totaled the number of
Likes
likes
and comments.
on comments, 3 times the number of comments, and you came up with an engagement index.
Mm-hmm.
I don't know what is that what you call it, or just engagement?
I just called it the engagement total score, the engagement level.
Sure.
That's how I've been referring
And so
to it.
in mathematics, or in the social science, taking multiple variables, each of these metrics is a variable, is called creating an index. And so what you've done is you've created an index. So you add those 2 and you create this index, and that's exactly what you did. You had a total score there. Well, when you do something called a correlation, a linear regression, which is what you did, you're just comparing 2 numbers. And those 2 numbers are, you're asking, as one increases, what happens to the other. So the dependent variable, the Y value, is what happens to engagement if these other things change. And of course, what we were talking about at the beginning is that maybe what was driving the change in engagement is what we call a third variable. And the third variable is,
influencing it. Yes.
How they become an influencer, all the work they've done in the years before.
Mm-hmm.
And it's hard, based on the data set that we have, to separate that out. And I believe that that's hugely impactful, and you did. But nevertheless, I loved what you were trying to do. So what you did is you took the two columns, right? And the first column is your independent variable, and that is the hue.
Yes,
So
the hue average.
Yeah, the hue average. And as the hue average becomes, shall we say, redder, does that also increase engagement? So what you did then is you created these regressions. And what was the first thing that we learned?
We learned, after taking all of these data sets and putting them into a graph, we learned that there's little to no correlation due to these previously talked about outside factors.
So, yeah, and partially what was going on with it as well was we have strong outliers based on the data, some that have huge engagement. And when you're doing correlations, very often that correlation might be is influenced by those outliers.
Yeah, we're talking about 25,000 versus 50 likes.
Exactly.
Huge gaps.
There might be some things that we can do next time, different kinds of correlations that take in exponentials and things like that. But just
could you describe what you mean by that?
So we're doing what's called linear correlation.
Yes.
And that's much more heavily influenced by outliers. And I was just thinking about this as we were talking about it, that maybe we can look at some other correlations that might enhance it. But we made a good solution, I think, by limiting the top outliers.
The top 10%.
The top 10%.
Of the most hugely liked posts.
Right.
Okay.
And what that did, and what we were primarily doing, was we were getting relatively close to what we call one standard deviation from the mean. Standard deviation is a measurement of one of several measurements of what's typical. And the standard deviation included all the low ones. So it wasn't a perfect, what we call normal distribution. It was highly skewed to larger.
Highly skewed
meaning that there was a lot more. That it was a lot more. There were the ones that were outside of the norm were large in terms of a lot more likes versus to the left where we didn't have quite so many that didn't have any kind of idea. And the ones on the right, the ones that were lots and lots of likes, they skewed the overall average more than going the other direction. So all we did is eliminate the top ones. Within a standard deviation. Actually, we chose 10%. And so, but even so doing, you had it on the hue. You had a trend line that went uphill a little bit. It did seem to show that the redder it got, right, that the greater
level of engagement.
The greater level of engagement.
If ever so slight, it was still there.
It was there. And it's measured in science using what we call the correlational coefficient. In Excel, they use the square of the correlational coefficient. Now, I don't remember what your number was. It was like 0.03 or something like that.
The hue level was 0.0078.
Yeah, which is extremely low.
Extremely low.
So what we're saying is there's effectively no correlation there.
Yes.
And then the same thing was true of the others, and they were both of those. I don't remember.
Interestingly, the saturation, as more saturation was added, the engagement level went down. It is still in the same level of correlation,
saturation
very
level
low.
To me means the more gray it got. No, the less gray.
Yes, the less gray. The more vibrant the colors were, the more in your face, so to say, the colors were, the less people interacted with it. If it was more neon, people were less likely to like it. Because oftentimes, in my opinion of interpreting the data, in action sports photography and landscape photography and wedding photography, you don't often like to see those really angry colors, the super bright yellows and the super bright greens. You want your wedding photos to be natural. You want your action sports photos to be natural.
So you are seeing higher engagement.
Yes.
What was the? That's a nice finding. What was the R squared value? Do you remember on that one?
Let me see. In the saturation, the R squared value was 0.0114, so much higher than the other ones, but still very low. Yes.
Very low. You know, when you're doing R-squared values, for it to be something that really got our attention, we'd be probably wanting to get close to 0.2. And if we got rid of some of our third variables, we might have got that close. Normally, in correlations, you divide it into 4 or 5 categories, very low to very high, and it's like 0 to 0.2, and then you go on from there. And remember that these are, I don't know why Excel does this, I should study it, but they use the square of the correlational coefficient, so it's more like 0.02 R value, but nevertheless, there we are. So
I'm sure that I don't understand.
Yeah, it's just kind of it. What I'm saying is it's very low.
Okay.
It's very low. And when you're trying to measure correlations and decide what is, should we say, meaningful or something to pay real attention to, it really depends on the nature of your data. If you feel like you have a relatively compact number of variables that might influence a result, and it has a high correlational coefficient, that R-squared value, the R-squared value, if that's closer to 1, then you really have something. There's some famous studies that are about that. Because this is so many variables, I think even if you got a correlational coefficient around 0.2, you'd find that to be really fascinating in these data. And you might, if you got rid of the third variable problem, that you have
even get a higher.
There's a lot of things that, it's going to have higher engagement if it's Jennifer Aniston, and those kind of things, and frankly the setting and.
So there's much more going on behind the scenes.
Behind the scenes.
Yes.
Right, the perceived beauty of the model or whatever. Right, there's a lot more stuff there that's going on. So it is interesting what you found. It isn't scientifically hugely, wouldn't get you a master's thesis, but that doesn't matter. That's what science is. We just see what we're seeing. So you are seeing something that seems to, so the redder it is, and now the second thing we're seeing directionally is
the brighter the color, the lower the engagement.
You did say that when you removed the outliers,
yes,
that in the saturation it actually was less powerful, and,
yes,
and what we call the trend line was less so. But that does indicate something, that the ones that had high engagement were more earth tones, if you want to call it that.
Yes.
So that does reinforce some of the things you're thinking. So brightness, what did you find?
Brightness, we pretty much found the exact same thing as hue, just a lot stronger. It's still low, but a lot stronger comparatively. The brighter that the picture is, the more range of the brightness, I should say. So the higher the contrast, the more blacks and the more whites together equals a higher level of engagement.
But also a very, very low
very low correlation. It's a 0.0363. So
that's your highest of the
That's
three.
The highest of the three, so contrast
that's getting kind of interesting.
Yes, it is the most impactful.
Yeah. So if you learned anything, you learned that that earth tones and a higher contrast range seems to slightly increase engagement.
Yes.
And if we were to do this again, I think we'd work really harder on our sample to try to eliminate some of the third variable problem that we did. And then I think after we talk, you're going to go and do one other thing, which is you're going to average. You're going to
average the hues.
To see if you can do it by average, but you're also going to see if there's a hue that maybe has the highest overall engagement.
So see if the Instagram community specifically likes a color
more
over
green
another.
Or something
yes.
like that. You also, I think, you didn't create the data this way, but I think there would also be something interesting to be said if you then further categorized by the 3 subcategories. That instead of just putting them in one group, you'd have 3 different groups and then see if, how those vary.
So we've just scraped the surface with this. There's so much more going on. This is the tip of the iceberg.
But you've actually learned something.
Oh, for sure.
You've
but we could
something.
Definitely delve deeper into this.
Yeah, there's a lot here. It's not strong correlations, but it's explained by your third variable problem. So it probably confirms what you already suspected. Strong contrast.
The earthy tones. We haven't yet gotten
what is the best color.
What the best color is yet.
But you're going to probably find that already because you figured that out with saturation. So interesting study. And I think it shows something about science. We were talking about this as we began. There's no such thing as a perfect research project. Had we had more time, we would have talked more about your sampling procedures, right? But that's all right. And then there's no such thing as a scientific project that is without value. And this even shows it. There are some issues relative to some of the things we're talking about, but it still kind of demonstrated something that is a hint of saying, that's kind of interesting. It
Absolutely
confirms what you're thinking of. So, nice job.
Thank you. Thank you for coming in and talking to us about all the data.